All right, in class, I just started section 4.2 and I didn't get as far as I wanted to, so that's why I'm doing this video. Of course, you have access to the notes, but this is to help you if you would like more help than that. So far what we looked at was basically our powers or our exponent facts. For example, you need to know that 7 squared is 49, or 5 to the negative 3 power is 1 over 125. Negative exponents lead to reciprocals, or for example, something to the 1/2 power, that's a square root. So we really need to know our rules of exponents well, and we need to know those exponent facts pretty well. And that's what we did up to this point. We also learned that exponential functions, we didn't have an opposite function or an inverse function for an exponent function. We now do. It's called the logarithmic function. And so that's what we're going to look at here. So our definition says the function y equals log base b of x is the logarithmic function with base b where b is greater than 0 and b does not equal 1. So that's just the same as it was with the exponential function. But the big thing is this, this definition here. So I already told you the first thing you need to do is master those exponential or your exponent facts. And so the second thing, and it's really huge, is you've got to know this definition, and you got to be able to go back and forth between logarithmic form and exponential form. So let's go ahead and look at this. First of all, this left side is read the log of x base b. The log of x base b. All right, so what does that mean? Well, let's look at the exponential form, which we're pretty familiar with. So b is our base, and then the y is, of course, our exponent. Now, x is sometimes called a power, but I'm just going to call it our answer here. And so we've got the same three parts when we have the logarithmic form, which is on the left. So notice the b is still our base. And since it's a subscript, I just call it the little guy. That's what I used, or that helps me to remember. That's my base. And then we've got the y, which was the exponent. And notice the exponent is all alone, so I call it the loner dude. And then x was our answer when we were in exponential form, and that goes right there. So we have the same three parts: base, exponent, answer. And so we just have to get used to where those three parts go. So let's look at the examples here. So again, I'll look at the exponential form 2 cubed equals 8. Or I'm sorry, before I do that, again, I want to point out that this is really the second thing you've got to master if you're going to be good at working with logarithms. You've got to know this definition or this relationship and be able to go back and forth between exponential form and logarithmic form. Okay, so now let's look at this example. Notice in this example, the base is 2, the exponent is 3, and the answer is 8. So in the log form, the base is the little guy, the exponent is all alone, and the answer is the other number. All right, so we can do the same. We can look at the same thing with the other examples here. Notice again, 3 is our base. Over here, 3 is the base. 2 is the exponent. Over here, the exponent's the one that's all by itself. In exponential form, the 9 is the answer, and that goes right here in logarithmic form. And same thing with the last example. We have a base of 4, an exponent of -2, and the answer of 1/16. There is a nice little way you can do this. I've seen this a number of different ways. So basically, what I like to do is go backwards from the log form. My base is the little subscript there, the 4, and then if I put an exponent of -2 on that, I get 1/16, and that's how I check myself. 4 to the negative 2 power is 1/16, and that's exactly what we have here. All right, so let's go ahead and do some examples. So if we look at number 6, of course, now we're supposed to write this in exponential form. So first of all, we want to know what our base is. That would be the little guy, the 5. The exponent, that's the one that's all alone. And then the other number is the answer. And notice 5 cubed is 125. If you got a false statement, that would be a pretty good indication you've done something wrong. Let's look at number 7. So here the base is, the little guy is 3. The exponent, again, that's the one that's all alone. And the answer would be x. So you might want to go ahead and try the next two and then watch the video. You could stop it. All right, so here you have a base of 10. Notice it's on kind of, it's just things are on the opposite sides. So we have 10 is our base, the exponent all alone, that would be the negative 2, and the answer, that's going to be 1/100th. Again, this is true. 10 to the negative 2 power is 1/100. And again, you could use that little trick I showed you earlier. If you take a base of 10 to the negative 2 power, you do get an answer of 1/100th. That's how I go backwards to check myself. And on the last one here, notice your base is e, the exponent, that's going to be the 1, and the last number would be x. All right, so now let's go from logarithmic form to exponential form. So the first thing I do is I write log for logarithm. And in this case, remember the little guy, or the subscript, that's my base. That's going to be 3 here. And I usually put my exponent all by itself on the other side next. And then the 81 goes here. So again, to check myself, it's 3 to the 4th power is equal to 81. All right, let's look at the next one. Write log. The base here, that's going to be the 9. That's my little guy. And the exponent goes all by itself. And then the other number is what I call the answer. So again, I would encourage you to do 12 and 13 and then watch the video to get the answers. All right, so here you write log. Your base is 5. The exponent is negative 1, and the answer, that'll be 1/5. That goes there. And on the last one there, you've got a base of 2, and the exponent is x, and the 5 goes right there. And actually, this is a problem we did earlier, one that we couldn't do. This is one where we had no exponent. We could put on a 2 that would give us 5. So now notice we have solved for x by changing this to exponential form. Later on, we'll actually learn how to find out what this equals. All right, let's move on to evaluating logs. So on number 14, the thing about a logarithm is a logarithm actually represents an exponent. In this problem, the logarithm gives you all the information you need to know what the exponent is. So on number 14, I'm looking for an exponent. It's the exponent you put on a base of 10 to get 100. So we're really trying to solve this here. So our base is 10. We want to know what exponent do we put on a base of 10 to get 100. And of course that would be 2. So this logarithm, which represents an exponent, it represents the exponent 2. So when I look at number 15, I want to know what what exponent do you put on a base of 2 to get 1/4? Well, I know 2 squared is 4, so I know 2 to the negative 2 will be 1/4, so it's going to be negative 2. So again, I'm really just asking, or in my mind, I'm saying, okay, 2 to the what power is 1/4? And that would be negative 2. All right, so on number 16, so I need to find an exponent that you put on a 4 to get 64. and that would be 3. So you can see this is why we have to know our exponent facts, because that's exactly what we're doing. It's really the same thing we were doing on the first page of the notes for 4.2. So go ahead and try the other 4. I will warn you, 19 and 20, you got to be a little careful. Those are a little bit tougher. And see what you can do, and then watch the video. All right, on number 17, let's see, I need to find an exponent that you put on a 5 to get 5. And well, that would be 1. On number 18, I need to find the exponent you put on a 3, a base of 3, to get 1. Well, anything to the 0 power would be 1, so the exponent here must be 0. So again, I'm just trying to find the exponent I put on a base of 3 to get 1, and that would be 0. All right, look at number 19. What exponent do you put on a base of 9 to get 3? So let's see, 9 to some power equals 3. Well, it's not some nice integer value. In fact, about the only thing we have left to look at it is this, because we know anything to the 1/2 power is a square root, and in fact the square root of 9 is 3, and so that's the one that works. 9 to the 1/2 power would be 3, because anything to the 1/2 power, that's a square root. All right, on number 20, we could actually rewrite this. In fact, we really need to. Whoops. Let's move on here. So this is the log base 5 of 5 to the 1/2 power. So the question I'm asking myself is, what exponent do I put on a base of 5 to get 5 to the 1/2 power? Well, it's almost too easy, but yet it can be a little bit tricky to see. It's just a half. So here's one way you could do this. Let me go ahead and say, I don't know what this is. I'm going to say it equals x. And so now I'm going to change to exponential form. My base is 5, so we're going to get 5 to the x power equals 5 to the 1/2 power. And now it's pretty clear that x is a half. So you could let the left side equal x, change to exponential form, and then it's pretty clear that x is a half. So the answer here is a half. All right, let's move on to the next page. We're going to talk about 2 special kind of logarithms, common and natural logarithms. These are the 2 that we used to use. They used to be a lot more important before calculators came around. But anyway, common log, which is log base 10, if you see log of x or log of x, that means the log base 10 of x. So it's understood if you don't write your base that it's a 10. With logarithms, or natural logarithms, or natural logs, ln of x means the log base e of x. It turns out that a base of e is actually very useful when you're working with logarithms in mathematics. And so this is another one of our logarithms that we work with a lot. So let's do some similar problems to what we did before with some of these, with our special logarithms here. So 21, the base is not written, so it's understood to be 10. And so if we're going to change this to exponential form, our base is the little guy, or the subscript 10. The exponent is the one that's all alone, that's the 2. And that's going to be the answer, the 100 there. And on number 22, well, this is a natural log, so our base is e. If it helps, you can write it in there. So e is my base, the exponent's the one all alone, and so that makes it e to the 1 power equals e, which is true. Let's look at number 23. It says write each equation in logarithmic form. So again, we'll write log. Our base is 10. The exponent goes by itself, and the answer goes right there. But again, when we write a log and the base is 10, we don't actually write the base. And so this is how we normally write it. It's probably best to put parentheses around the fraction there. And you might try 24 and then again watch the video. All right, so logarithm, this is going to be a base e log, and the exponent is 0. That's the one that goes by itself, and then the 1 will go right there. But again, when we're dealing with logs, if it's a base e log, we use ln to represent that. So this is the natural log of 1 equals 0. So by writing ln, it's understood that the base is e. All right, now we've got some logs to evaluate. So on number 10, again, it's kind of helpful if you put in a 10 there. That's your base. Again, if it's not written, it's understood to be a 10. This is a common log. So as we evaluate this, remember a logarithm is an exponent. It's the exponent you put on, I should say number 25. This log of 10 is the exponent you put on a 10, a base of 10, to get 10. Well, 10 to the first power would be 10. So again, 10 to some power is 10, that's going to be 1. All right, so again on number 26, I'm going to go ahead and put in the e, that's my base. So what exponent do you put on a base of e to get an answer of e? Well, that would just be 1. Number 27, it's a little bit harder to see. You might want to look at your base 10 logs. This is a base 10 log, common log. So it's got to be a negative power of 10, because if it were like 10 to the first power, that'd be 10. 10 squared would be 100. So 10 to the negative 1 power, that's 1 over 10, or 1 over 10 to the first power, which is 1/10, which we could write as 0.1 or 0.1. 10 to the negative 2 power, that would be 1 over 100, or 1 over 10 squared, which is 100. And so that would be 1/100th, or 0.01. So 10 cubed, you would get 0.001, and 10 to the negative 4 power, you'd get 0.0001. And so the answer here, the exponent that you put on a base of 10 to get 1/10,000th, is negative 4. All right, number 28. Again, this is similar to one we did earlier. What exponent do you put on a base of 2 to get 2 to the 5th power? That's just going to be 5. Or on 29, our base is e. What exponent do you put on a base of e to get e to the negative 5 power? Well, that's negative 5. Now, if you're just not seeing it, again, I would encourage you to set the logarithm equal to x and change to exponential form. And when we solve for x, we know our answer. So it's a base e log, and so we're going to have a base of, when we change to exponential form, the base is e. To the x power, x is my exponent, and the answer would be e to the negative 5. So again, it's e to the x power equals e to the negative 5, which is what we have here. So you can see that x would have to be negative 5. And so that is the answer. That is the value of this logarithm. All right, so that does it for the notes on 4.2, at least for now. We still have the rest that we'll finish next time.